A spectrum refers to the range of different wavelengths of light, or other types of electromagnetic radiation, emitted by a source. In lighting and color science, the light spectrum shows how much light is being emitted at each wavelength, from short, blue or violet, to long, red, wavelengths. The visible spectrum is the portion of the electromagnetic spectrum that humans can see, approximately from 380 to 780 nanometers. A light spectrum diagram, similar to a graph, visually represents the distribution of light across different wavelengths, or colors. It typically shows the intensity of light at each wavelength, helping you understand the composition of the light source. A wavelength is the horizontal distance between two peaks of a wave. Light is measured by its wavelength, expressed in nanometers, nm. The dominant wavelength refers to the specific wavelength of light that appears most prominent or representative in a color composed of a mixture of wavelengths. It indicates the perceived hue of the light. This is the wavelength at which the light spectrum reaches its maximum intensity. It can be identified as the highest peak in a spectrum graph. Peak wavelength indicates the brightest part of the light spectrum. Dominant wavelength, on the other hand, represents the color we perceive from the light. This is the actual intensity value at the peak wavelength. It shows how much light is being emitted at that specific wavelength. Chromaticity is a way of describing the color of light, regardless of how bright that light is. In technical terms, it's the objective measurement of hue and saturation, without considering luminance, brightness. So while brightness tells you how intense a light is, chromaticity tells you what color it is. It's usually represented using coordinates on a chromaticity diagram, like the CIE 1931 diagram, which maps colors based on their spectral. In short, hue equals the type of color, red, green, blue, etc. Saturation equals how vivid or dull the color is. Chromaticity can be represented as coordinates calculated from the spectral power distribution, SPD, using a color diagram published by the International Commission on Illumination, CIE. The CIE 1931 chromaticity diagram uses X, Y coordinates to map chromaticity. A pair of these coordinates provides a numerical representation of a light source's color. Dove, short for delta U, V distance, is a measure used in lighting to describe the deviation of a light source's color from the blackbody locus on a chromaticity diagram. The blackbody locus represents the colors of light emitted by an ideal blackbody radiator at various temperatures, which are generally perceived as natural and pleasing by the human eye. Dove quantifies the distance between a light source's chromaticity and the nearest point on the blackbody locus in the CIE 1960, UV, chromaticity diagram. A positive dove indicates the chromaticity is above the blackbody locus, often resulting in a greenish tint. A negative dove indicates the chromaticity is below the blackbody locus, often resulting in a pinkish or magenta tint. A dove of 0 means the color lies exactly on the blackbody curve. This is considered ideal white light. Light sources with a dove close to 0 are generally preferred, as they produce light that appears more natural. Typical recommended dove range. General lighting, -0.006 to +0.006. High quality lighting, -0.003 to +0.003.